Okay, equilibrium of a rigid body. So, ano ba yung conditions para masabi natin na yung rigid body natin ay in equilibrium? Okay, dapat yung resultant force and couple moment natin are both equal to 0. So, equate lang natin yung summation of forces and summation of moments natin sa 0. Ganun lang siya. Then, kapag ganun na, syempre, pag sinamation mo sila lahat, it will be equal to 0. Then, it is said that the body is in equilibrium. So, mathematically, pwede natin yan express by these three equations here, summation of forces vertical, horizontal, at saka yung summation of moments. Kasi, ibig niya sabihin lang dyan, babalik lang tayo dun sa physics natin, sa law ni Newton. So, sabi niya doon, in every action, there is equal opposite reaction. So ngayon, dahil equal sila, pag kinoma yung summation nilang dalawa, na ni action at saka ni reaction, their summation is equal to 0. Kasi equal sila. And yung rigid body natin, ganun din. It is in equilibrium kapag ganun yung action, yung mga forces na ina-apply natin. Reaction, that is the reaction of the body. Okay, equal yan sa 0. And also their moments. Ayan. So, ayan lang yung tatandaan natin. So, take note lang natin, we will always have the summation of forces vertical equal to 0. At ang assumption natin dyan, positive yung going up. Okay, laging tatandaan. And summation of forces naman, horizontal, is equal to 0. Tapos, positive going to the right ang assumption natin. And last is yung summation of moments is equal to 0. Positive yung ating clockwise. So, dito lang iikot yung mundo natin pagdating sa equilibrium of a rigid body. Okay, so we have here some common support reactions. Start natin, roller. Si roller, ano ba yung reaction niya? Okay, example, yung roller natin pwedeng bilog. Ayan. O di kaya naman, ganito yung itsura niya. Ayan, gulong, kumbaga. Yung roller na yan, ang reaction lang yan ay isa. Okay, and that is force na perpendicular doon sa kanyang support. Ayan, so ito yung support natin, roller. So, meron lang siyang force na vertical dyan. There are cases din na yung ating roller ay naka-inclined. Ayan. So, ang gagawin lang natin dyan, kunin yung reaction dyan, which is always perpendicular yung reaction doon sa ating support. Ayan, that is our force reaction. Okay, next. Meron din tayo nung tinatawag natin na pins. Drawing lang natin. Pag nakita nyo, ganito yung drawing, triangular. That is pin, o di kaya naman ay hinge. Yan, isa lang yan. Okay, ngayon, yung reaction yan ay given by FV, force vertical, and then force horizontal. Ayan yung forces natin na nagpre-prevent ng tinatawag na translation or rotation yung ating body. Kasi nga, dapat rigid siya, di ba? So, next natin naman is yung tinatawag na fixed support. Yung fixed support, tatlo naman ngayon dyan yung reaction natin. Siyempre, meron tayo nung vertical, FV, meron tayo nung horizontal, tapos meron tayong moment. Ayan. Kasi dahil nga fixed siya, magka-recreate siya ng moment. So, ayan yung ating mga common supports. Ngayon naman, apply na natin siya doon sa iba't ibang force systems natin. So, let's move ahead. Okay, example number 1 natin. Okay, for example number 1, for concurrent force systems. Okay, ano ba yung concurrent? They meet. Okay, the forces meet at a common point. So, the members of a truss are pin connected at joint O. Sa joint O, yan. Nag-connect sila sa joint O. At ang sabi, we will determine the magnitude of F1. Ito yung si F1. And its angle theta. This is the theta. For equilibrium. Okay, for equilibrium, kailangan the force F1 ay pag sinamation natin silang lahat, ang makukuha natin ay 0. Okay, and then we will set F2 daw as 6 kilonewton. So, si F2 will be equal to 6 kilonewton. Okay, so balikan natin yung mga concept natin kanina for equilibrium. Okay, ano ulit yun? Review lang natin. Diba, we have our summation of forces vertical. Assumption is positive going up. Meron tayong summation of forces horizontal. Going to the right, positive tayo. And then we have our summation of moments, which is positive ang ating clockwise. So, dyan lang tayo maglalaro. Solve na natin. If we take summation of forces vertical equal to 0, So, positive going up tayo. Ngayon, we have our forces here. Kailangan malaman natin yung kanilang components. Okay, di ba? Ang force na naka-angle ay may component yan. So, ngayon, unahin natin yung vertical. So, for F2, it is going to the right up. So, ibig sabihin, up yung kanyang component, vertical. Si 5 kilonewtons, ganun din, going up. Si 7 kilonewtons, since it is going down to the left, so going down din yung kanyang force na vertical. Tapos si F1, same din. It is going down, pero to the right siya, going down din itong ating component for vertical. Yan. Tapos, i-take note lang natin yung binigay sa atin na slope. For 7 kilonewton force, we have 3, 4, and then 5. Okay, so ganun lang siya. Kunin na natin yung mga summation ng ating forces vertical. Unahin natin si 6. So we have 6 kilonewtons times, okay, since yung ating angle ay coming from the y-axis, so yung vertical natin magiging cosine. So 6 cosine 70. Tapos, yung ating 5 kilonewtons going up, so plus 5. And then, our angle is 30, so we will have sine 30. Yung 7 natin, it is going down. So, minus yan, minus 7. Then, yung slope natin, vertical, so we will use 3. 3 over 5. And then, our F1 minus F1 sine theta equal to 0. Tapos, pag kinuha natin yung summation nitong tatlo, we will have 0.3521 minus F1 sine theta. Okay. Ngayon, ang kailangan natin si F1. So, gawa tayo ng equation for F1. Ilipat natin si F1 sa kabila. So, we will have here 0.3521. Okay, this is equal to F1. Tapos, divide natin ng sine theta. So, now, that will be our equation number 1. Next, let's have summation of forces horizontal naman. Equal to 0, so that it will be in equilibrium, positive ang to the right. Okay, so, isa-isahin ulit natin. Ang component niyan, si F2 natin, si horizontal niya, going to the right. Okay, si 5 kilonewtons, magiging to the left, syempre. Si 7, to the left din. Down to the left kasi siya. Si F1, down to the right. So, it is going to the right. Ayan. So, alam na natin yung mga direction. Then, let's find the components. So, si 6, again, the angle is coming from the y-axis. So, yung horizontal will become sine. So, we will have sine 30. Tapos, yung 5 kilonewtons natin, it will be minus. Kasi to the left siya. So, 5 cosine 30. And then, 7 is also negative. Tapos, we will use naman 4. Okay, dun sa ating slope. So, 4 over 5. And then, yung F1 natin, that is positive kasi going to the right siya. So, we will have F1 of cosine theta equal to 0. Okay, huwag kakalimutan. Pag kinuha na natin yan, sinimplify pa natin, we will have minus 4.2919 plus F1 of cosine theta equal to 0. Okay, so kailangan natin si F1. So, ilipat na lang natin si negative 4.2919. So, we will have F1 is equal to 4.2919 over cosine of theta. So, this is our equation 2. So, may equation 1, equation 2 na tayo. At kung mapapansin natin, F1 and then F1. So, pwede nating sabihin na 1 and 2. So, our equation 1 is F1. That is equal kay equation 2 F1 also. Okay, so pag sinubstitute na natin yan, F1 equation 1, we have 0.3521 over sine theta. Equal yan kay F1 equation 2, which is 4.2919 over cosine theta. Okay, at alam natin na 'di ba yung sine over cosine is tangent. So, ilipat natin ito. Okay, so pag nilipat natin yan, we will have sine theta over cosine theta. Okay, tapos yung 4.2919 sa kabila naman. Lipat natin sa baba. So, 4.2919. Okay, and then we have here our 0.3521. And we know sine over cosine is tangent. So, we will have tangent theta is equal to 0.3521 over 4.2919. Okay, therefore, our theta will just be the inverse tangent of 0.3521 over 4.2919. So pag sinolve natin yan, our theta will be 4.69 degrees. So we have our theta now. Tapos, since alam na natin yung theta, we can use any of our equations dito, yung F1 natin. Pwede yung equation 1 or yung equation 2. So if we are going to use equation 1, so F1 will be equal to 0.3521 over sine of our theta, which is 4.69. Yan. So therefore, F1 is equal to 4.31 kilonewtons. Okay, so that is how we use our summation of forces vertical and horizontal in solving our concurrent force systems. Next, okay, for parallel force systems naman tayo. Ayan, so we have here our beam. Okay, and ang kailangan natin ay i-determine yung components of reaction at the fixed support. Let us recall, 'di ba, ang ating fixed support ay merong tatlong reaction. So meron tayong force vertical, meron tayong force horizontal, and we have our moment. So tatlo nga hanapin natin ngayon. Okay, so gawin na natin. We have here our beam. Ito yung ating support at A. Okay, so sabi natin tatlo yon. So we have our A vertical, then we have our A horizontal, and we have our moment later on. Moment A. Ayan. So let us start. Okay, solve muna natin. Summation of forces horizontal, for example, equal to 0, positive going to the right. Okay, ngayon pag titingnan natin, ang ating horizontal ay AH lang. Wala nang ibang force na nandyan na horizontal. So therefore, our A horizontal is equal to 0. Next, summation of forces, let's try vertical. So we have summation of forces vertical equal to 0, positive ang going up. Check natin ano yung mga vertical. AV, it is going up ang assumption natin, so positive siya. Then we have tatlong 200 dito na going down, so we will have minus. So minus 200 minus 200, and equal lang yan kay 0. So therefore, our AV is equal to 600 newtons. So that is our AV. May reaction na tayo. Nakasolve na tayong dalawa. Yung isa 0, yung isa 600. Okay, ngayon, solve naman natin yung moment. So gagawin natin dyan, summation of moment at A equal to 0, positive ang clockwise. So assumption natin dito, moment A is counterclockwise. So gagawin natin dyan, minus MA, minus moment A. Tapos, iikot lahat ito, 200, 200, and then 200. So ang gagawin, pwede natin gawin, get the moment here. Okay, 200 times this distance x, sabihin natin 1. Tapos yung 200 ulit dito, sabihin natin at distance x sub 2. Tapos yung huling 200 at distance x sub 3. Kaso, hahaba yung equation natin kapag ganyan. Ngayon, pag ino-observe kasi natin, pag obserbahan natin yung ating beam dito, pare-pareho silang 200. Tapos, equidistant silang tatlo. So, kung equidistant sila, pare-pareho sila ng distansya sa isa't isa, then the resultant of these three forces ay tatama lang dito sa gitna nila. So, wag na nating pahirapan yung sarili natin na hanapin yung tatlong moment arms. Okay, so gawin natin ganon. Okay, so ngayon, alam natin na ang resultant ni 200 dito, 200 plus 200 plus 200, alam natin na iyan ay 600 newtons. Tapos, tatama siya sa gitna kasi pare-pareho lang sila ng distance sa isa't isa. So, tatama yan dyan. Yan yung kanyang line of action. Yan. Tapos ito yung A natin, point A. Okay, it is here. Ayan si point A. At ang yung distance niya dyan ay perpendicular. Sabihin natin, it is distance X. Kaso may problema pa pala tayo dyan. We have here 1 meter, pero yung distance dito ay hindi natin alam. Okay. Dahil di natin alam, tawagin natin siyang distance D. At isolve muna natin siya. So pag solve natin yan, let's just draw a triangle. So we have our D, 3 meters, tapos at 60 degrees yan. Okay, so masolve na natin siya agad. Cosine of 60 degrees lang. Ano yung adjacent? That is D, hypotenuse is 3. So D will be equal to 1.5 meter. So may D na tayo. So ibig sabihin, our X here is 1.5, which is yung D plus 2. Itong 2 meters na to. So, this is equal to 3.5 meters. So, now, our summation of moment at point A is given by moment A, that is negative kasi counter siya. And then itong 600 na iikot. Okay, yung ikot niya is clockwise. So we will have plus 600 times 3.5 meters equal to 0. So MA yung hinahanap natin, ilipat natin siya. So we will have positive MA equal to 2100 Newton meter. Okay, so that is our answer. Ayan na yung ating mga support reactions. Okay, so again, recall lang natin, no? Laging tatandaan lang yan. Summation of forces vertical, positive going up. Summation of forces horizontal, positive to the right. Summation of moments equal to 0. Okay, equal to 0 lahat, positive clockwise. So, ayan na yung bubuhay sa atin for equilibrium. Okay, next naman, let's go to non-concurrent force systems naman. Okay, for non-concurrent force systems, ibig sabihin, the forces are not parallel. Okay, wala rin silang common point. Observe muna natin yung ating truss. May truss na binigay sa atin dito. Recall lang natin to. Pag hinge support, dalawa yung ating reaction. So, we will have AV and then A horizontal. Tapos, may B vertical din tayo. Given here, B vertical. Okay, isa lang kasi roller support siya. Okay, so pwede na tayong mag-start. Okay, unahin natin, halimbawa, summation of forces, horizontal muna tayo, equal to 0, positive to the right. Tingnan natin yung mga to the right natin na forces. We have our AH to the right, so it is positive. We have 5 kilonewtons, 5 kilonewtons, equal to 0. So, pag solve si AH, lipat lang si 5, magiging negative. Okay, since negative yung lumabas, ibig sabihin mali yung direction natin. Ibig sabihin si AH ay 5 kilonewtons, pero to the left siya. Ibig sabihin si AH ay mali. Mali yung ating assumption. So, pag lumabas sa inyo negative, ibig sabihin lang nun, mali yung naging assumption. Okay, next. Let us solve summation of forces vertical naman equal to 0. Positive going up. Ngayon, pag-obserbahan natin, ano yung mga forces natin na vertical? We have AV. We have BV, tapos yung action natin na dalawa, yung loads. Kaso, ang problema, may dalawa tayong reaction na nawawala, unknown. So, ayaw natin na dumadami yung unknowns natin. So, ang gagawin natin, hindi muna tayo mag-summation of forces vertical kasi magkakaroon tayo ng dalawang unknown. Ayaw natin yon. So, ang gagawin natin, we will take the summation of moment. Pwedeng sa A, pwedeng sa B. Okay, it is up to you. So, ngayon, gawin natin sa A equal to 0. So, summation of moment, A equal to 0. Positive ang clockwise. Ngayon, kapag nag-moment tayo kay A, dito sa point A, si AV at saka si AH, wala nang moment arm kasi tatama sila sa point kung saan tayo mag-moment. Okay, so ang matitira yung 5, 6, 8 at saka yung unknown na BV. So, start natin. Yung 5 natin, pag iikot yan kay A, sa point A, ito yung perpendicular distance niya, which is 2 meters. At ang ikot niya ay ganitong manner, so ibig sabihin that is clockwise. So, we will have 5 times 2. Okay, next, yung 6. Yung 6 natin is, ang ikot niya is pareho lang, clockwise. So, ibig sabihin plus 6, and then yung moment arm mula kay A ay ito, 2 meters. Times 2. Then 8 kilonewtons. Paikot din natin yan kay A. Dito kay A, ang ikot niya ay so plus 8. And then ang moment arm ay 2 plus 2. So that will be 4. And then ito lastly, BV natin, B vertical. Reaction at B. Ang ikot niya ay counter naman. So dahil counter siya, it will be negative. So BV times yung moment arm 2, 4, 6. Equal yan sa 0. So lipat natin si BV sa kabila. So B vertical and then retain ito 5 times 2 plus 6 times 2 plus 8 times 4 over 6 para makuha natin si B vertical. And that is equal to 9 kilonewtons. So we have now our B vertical. Okay, ngayon since alam na natin si B vertical, nabawasan na yung unknown natin sa vertical na mga loads, pwede na natin mahanap si AV through summation of forces vertical equal to 0, assumption positive ang going up. So, mga going up natin, AV, so positive kasi going up. Yung 6 natin is minus 6 kasi going down siya, minus 8 kasi going down, plus B vertical kasi going up. Wala nang ibang vertical, so that is equal to 0. Okay, so we have AV minus 6 minus 8 plus yung BV natin dito, which is 9. Equal sa 0 yan, we will have AV equal to 5 kilonewtons. Okay, so that is the 5 kilonewton natin, going up siya. Ayan yung ating reaction at A, vertical. Okay, ito namang B, vertical natin is going up din. So that is how we use the summation of forces and summation of moments in finding reactions, solving different force systems. So recap lang tayo, laging tatandaan, summation of forces, vertical equal to 0, positive going up. Summation of forces, horizontal equal to 0, positive to the right. And then summation of moments equal to 0, positive ang ating clockwise.